Today we're going to talk about the geospatial library that we have and how to leverage our geospatial tools and resources. For those of you who do not know, we are under the Division of Technology Services, DTS, and we're the Utah Geospatial Resource Center. So we are an office of 12, and you're going to get to hear from 5 of us today. So almost half of us are going to be speaking. We'll do a quick introduction to us, and then each of us will have an opportunity to present on a different topic. So in no particular order here, we have Jake Adams. He's one of our developers. He's a data analyst and a cartographer in the office. Sean Fernandez, who's the state surveyor, works with local surveyors, the BLM, and our real-time GPS network. And then Zach Beck is our state cartographer, and he works with address points, and he's kind of one of our liaisons to the local as well as Google and other of our partners. He keeps up the relationships there. And then Steve is our lead developer, and he focuses a lot on our system architecture, our web API, web development, and make sure our back end and front end stuff is running clean and looking clean. And then I'm the data coordinator, and I work a lot with 911, elections, and transportation related data. Some of the tools we're going to be talking about how to leverage today are our most popular ones, of course. It's maps, GPS, data analysis, some of our services, and that includes our human services that we provide, and our data, and then the API. So you'll get to hear on all of these topics from a variety of us, and we'll circle through. We'll each take about 10 minutes to do so. So I am going to lead us off and talk about data out of the gate, and then I'll pass it on to the others. So when we talk about data in the office, we talk about the SGID. That is our primary data source. You may have heard this. I think it kind of, the more I say it, the more it rolls off my tongue, SGID, the more I like it. So it's the State Geographic Information Data Source. And you'll hear that out of our office quite a bit when you're looking for data. Well, it's probably in the SGID. Did you check the SGID? So really, what is it? Really briefly, it was a concept that came about in 1982. So this thing has been around for a while. At that time, it was the State Geographic Information Database. And in 82, we were established as an agency with the notion that we would work with other agencies in the state and entities and create a database and bring in data from other agencies within the state. That was the concept. In 1991, it really got codified. So the SGID goes into code in 1991 as something that our office will maintain and will do. From there, at that point, it's still a single database. So if you're working with us, you would hand off data to us. We would put it into this database and then figure out how to make it available to the folks who needed it. So let's bump forward to today. And really what it is today is it's a live ecosystem of data out there. It's no longer a single database, which is why we're using the word data source or data catalog. And this is a really high level, quick snapshot of, this is not inclusive by any means or all inclusive. This is showing just a couple of samples. We're one of the players in this ecosystem. We've got UDOT, Wasatch Front Regional Council, SITLA, UTA, and then local governments make up a lot of this. So the point being here is this data is live. We're trying to get away from handing off data, but more directly tapping into these data sources that are out there and getting more live updates. So the concept of the SGID at this point, the way we see it is it's a catalog in a sense. So there are many ways to look at it. You could access a catalog just by browsing. So if you're interested in boundary data or economic data, you can open up the SGID catalog and browse what we have available for in economic data. Another way to approach it is just to search directly for a layer that you're looking for. And I liken the search tool to like Google. You go, it's going to point you to a data set. It's a pointer to where the data is, but it's a great entry point to it. But really, this data is, the whole thing works because it's built on partnerships, relationships, and agreements. as you saw in 1991 or even the 80s, this was established. So this thing, the SGID, has been in existence for a long time, and throughout those 30 plus years, we have created many partnerships and relationships with these folks. So that's the secret sauce to the SGID, is that we often have one-on-one relationships with our data stewards. They're partners with us. We're working toward the same thing, toward standardization. And then we have agreements on how to keep this data updated and accurate for the end user, with fair notices of change. So if something's going to change, we're able to push that information out to our end users. And then this slide really is focused on how it works with our local stewards. So if you think about a local steward, let's think about a city or a county, and they're maintaining data. So they're working at their level to maintain address points, road center lines, parcel data, and that's great. That's in their world. But our job is to come in and pull it together. On this graphic on the left, to pull in all the sources on some of these data sets that we call our framework data sets that go into our base maps. Work with them to produce a seamless statewide standardized data set for base maps that we can push out and our end users could use as a seamless statewide data set. So this is oftentimes local data that is bubbling up to a statewide data set. It's framework, and it's a single source of truth. So ideally it's the same data that the locals are using that you would use at the statewide level. We'll push this data into our base maps, our locators, our API, and this is all free to use. It's just another way to access this data. Google, Apple, USPS, they also pick up data from us, and they'll also create locators and base maps. Theirs will come with a charge depending on how you're using it, but ours will always remain free. Real quick on the demo. So our web page is changing, as you all know. Everyone's is going to be changing here in the coming months. But the idea is that you will come to our web page, the UGRC web page, and we'll make it very clear how to access the SGID. And back to the whole catalog and browsing. You can see we have categories here on how to browse the SGID. If that's something you're just out looking for, maybe you're looking for, what do they have in the ballpark of boundaries? You can see we have judicial districts, parcels, and land ownership, and voting precincts and zip codes, a variety of data sets in a variety of categories. But maybe you really just want to search because you know exactly you're looking for address points. So this is one of the things I'm kind of excited about and have been the most excited about on the ways to access the data is what we call the SGID search index. And again, this is much, I liken it to Google, where you can go in and just type what you want. And maybe it's address points. So type in address, and I can see coming up right away, related to addresses, there's a couple of categories of transportation. There's roads. There's address points. Let's see what this is. So you click on address points here, it's going to take you to a data landing page. Most of the data that we serve in the SGID has a landing page that tells you about the data set, some metadata here, and then how to access the data. So from here, you can download the data or you can hit our web services. So this link here, and this is pretty much the same format for all the data that we provide on our web page. It'll bump you out to a different platform here. This is a third-party application who hosts this data for us in the cloud. It's a company called Esri. They are the leading provider of geospatial data, particularly for governments. And this data we push up to them nightly, or make sure it stays current on a nightly basis, and it's hosted there in the cloud. And you can see you get to check out the data. It's clickable. The address points, it'll open up. It'll show you some of the attributes that are associated with this address point data and other ways that you can consume it. You can download the data from here. You can get a CSV, a KML, a shapefile, some open source GeoJSON or a file geodatabase, or you can use the data in this way. And really, it's a little confusing. So it's downloading or using. Using meaning you can get a REST endpoint or a URL to plug this data into your applications. And it's essentially just copying it from there. You can also create a simple map from here. I won't go into that. It takes a little time, but you're able to create a quick map and add other layers as well. So that really is accessing our data as downloads and web services. However, there are other ways to access the data. Maybe you want a direct database connection into the data. You want to just hit the SQL database itself, and that's possible as well. On our data page, there is a link here that goes out to accessing what we call the Open SGID, and this is hitting out to a SQL database, and you're able just to hit it directly, and I'll show that really briefly, but here's how you would connect. I'm using the dbeaver application, just an open source data management tool that allows me to hit our data. As you can see, I'm connected to the database. I can see it's called Open SGID. There's a variety of, and now you're seeing the categories. There's a variety of categories, the same ones you'd see on our landing page. So I'm in the recreation category here, and I'm browsing, and I found local parks. That's interesting me at the moment. So let's explore that in a SQL world. So I can run directly on this right from here. So this first query is, I want to see what are the biggest local parks that we have in the state in the database. And I'm ordering it descending by the acres. So you can see what comes up right away. The first result is Corner Canyon Regional Park, and I can see that's about 1,000 acres. You can scroll through this and check out other parks and other data as well. Another quick demo for a query would be, all right, well, that's interesting. It's 1,000 acres. What's the average acre in the state for local parks? You can run the average function and see that it's 10 acres. So Corner Canyon is pretty big, actually. The last thing I want to demo is we can look at this data spatially as well in dbeaver and other database management tools by running some simple functions here. But what I'm doing here is I'm running a function that's going to map it and transform it into a projection that allows me to project this data onto a map here. And I'm saying, hey, show me, do a quick query on our regional parks and show me, let's take a look at Corner Canyon Regional Park really quickly. So there's a spatial tab here, brings up a world map, and voila, there's Corner Canyon that's sitting in our database. You could click on it and see that it's, all the attributes about it. It's a regional park and it's in Salt Lake County. So that concludes my demo on data, and I'm going to pass it off to Jake. He's going to talk about our imagery and some other mapping tools. So,
howdy, everyone. So like Greg mentioned, I'm going to talk a little bit about our aerial imagery and some other stuff. Now, a lot of times when you're working with GIS data or anything that has a location associated with it, you really want to know what's around it. You want some context to it. So the state has licensed some high resolution aerial imagery from the provider Hexagon that is available to any state agency, also any city, county, higher education, that sort of, under that state umbrella. Anyone can use this, and it's really high res. So if we just zoom down into, let's see, my old high school is being rebuilt, and so you can see we can get in really nice and close. That's my old middle school. That's my old high school. They're both getting rebuilt. We also provide other imagery as well. We have a copy of the NAEP imagery. This is a federal program that provides aerial imagery, and this is available to anyone. You don't need to be a state agency or anything like that. You can see that the resolution on the NAEP isn't quite as good as it is on our data. You can get down, you can start counting parking stalls or these cooling towers. Our last talk, we mentioned how we used machine learning to find all these cooling towers in our aerial imagery. So this aerial imagery is free and available to everyone. Anyone in the state, you just have to sign up. You can find links on our webpage. Now, if you want to download raster data, and raster data is things like aerial imagery, elevation, that sort of thing, you can find it on raster.utah.gov. So let's say I want to go download all the NAEP imagery for my county. I'll just select aerial imagery, select Utah County, and I want the NAEP county mosaic, and there I can download the county mosaic for all of Utah County. So that's how I can get a copy of that imagery. Or once you've signed up on the high-res imagery, you can just go to this download and I can get the individual tiles. UDOT, a lot of their contractors use this a lot for getting really good detailed imagery of areas where they need to be doing some work. Now, another thing that Greg talked about was ArcGIS Online. This is the cloud platform that our vendor Esri has for storing, editing, and displaying spatial data on the web. It is both a data repository and also a place where you can do low code or, well, frankly, no code, web maps, story maps, dashboards, a whole wide variety of things. So you can see we've got some layers in here. I can pop in here. And just like the data that Greg was showing you through dbeaver, we can come in and we can look at the tables. We can look at it on a map. And you can really use this data for any sort of spatial analysis that you do. We have a license for ArcGIS Online. A lot of other agencies throughout the state also have licenses for ArcGIS Online. So if you're working with somebody who has data that they want on a map, ArcGIS Online is really the lowest barrier to entry that there is for getting this up there. So what do these maps look like? Well, here's a map I'm currently working on. This is just kind of a scrolling map. You can see I put this all together in a WYSIWYG editor, but I can search and it'll pull up our locator that goes directly to our data to find where these addresses are. I can click on this point and I can get directions to it. So we've got a built-in directions widget. Just start typing, get my hint, and there's my route to that location. You know, turn-by-turn directions, just like you get with Google or Apple Maps or anything else like that. So how do we build this? Well, Esri has their experience builder, and this is what you see is what you get builder. You can see I'm doing a scrolling page, but I can do multi-page apps. I can link these buttons up. I can add in widgets to turn on layers, turn them off, filter, do all sorts of fun stuff with this. And this is all, again, no code. You just get your data in ArcGIS Online and display it. It can also do dashboards. This is a dashboard we put together for the state speed test campaign that the Governor's Office of Economic Opportunity has been spearheading. And you can see this is a map-oriented, a map-focused dashboard. So right now we're showing the entire state, but I can drill down into, say, Salt Lake County, and it updates the values of the dashboard with to only consider that particular area. And I can filter it down even further. And again, this was all built without code, really easy. The ArcGIS Online provides a wealth of mapping tools that go far beyond what Salesforce or Power BI or any of these other kind of no-code solutions provide, because ArcGIS Online is focused on spatial data at its core. It is mapping, and it does it very well. But let's say you're already using Salesforce or Power BI or some other kind of source of truth, record of truth data set or database to store your data. How do you get it into ArcGIS Online? Well, this is a common problem that we help solve very frequently with our other agency customers. And so we put together a Python library that we call palletjack. Palletjack is a way to pull data in from all these different locations and get it into ArcGIS Online so that it can be mapped, it can be analyzed, it can do all this really cool stuff. Now, if you're familiar with the ETL process, extract, transform, and load. You know, every project that you do, you're going to have some custom business logic that is very specific to your project. But then all that extract stuff and all the load stuff is going to be repeated over and over and over again because you're getting it from the same sources and you're all putting it into ArcGIS Online. So we built palletjack to take care of all that complicated extract and load so that you can focus your development time on the stuff that makes your app, your project unique. Gets all that other stuff out of the way, you can focus on what you're doing. I like to kind of think of this as a meat grinder, right? You've got all these different sources and you're pulling them all into one location, and palletjack provides the connectors, the data pipeline to pull it all in. Some, common transformations, but allows you to do your custom transformation. And then it provides the loader to get that all up into ArcGIS Online. Now, because this is a library, you'll write your own script that uses this, and that script can be run locally. We run it in Google Cloud Platform for a lot of our things, either as a cloud function or for larger things that take longer to run as a Google Cloud Run project. And this means it's really easy to spin up and it just keeps going. I've had stuff running for over a year now on this, and it just works. This here is an example of one of our reports. And you can see this is a larger project. It takes about an hour to run, but it's updating thousands of records from a federal data source that isn't always the most reliable for live data, so we pull down a local copy. So palletjack can really help you take your data from Salesforce, from SQL, from Google Sheets, from whatever it's currently in, and get it up into a spatial format so you can then map it, analyze it, and find out all those questions that, or all those answers that maps can really help provide the answers for. Now, ArcGIS Online has a ton of out-of-the-box tools that make it really easy, but sometimes you want to really dive in and get more custom. Well, Esri has tools for that too, and I'm going to go send it over to Steve so he can help teach us more about the custom tools that are available to developers. All yours, Steve.
Thanks, Jake. That was pretty cool. I'm going to start by going over our UGRC API. This is a web-based API that you can access all of our SGID data through, and you can search all of and you can also do like some geocoding things as well. So I'm just going to go through the endpoints real quick, just so everybody gets an idea of what is possible. Kind of the bread and butter and what sort of draws people in would be our street and zone address geocoding. So this basically takes an address and it gives you coordinates for that address. So if you have a database full of addresses, you can spatialize it, so now you can run it through our geocoding endpoint, and then you can see your database records visually on a map. We also have reverse geocoding, which is the opposite. You take a coordinate and then you guess kind of what address is behind that coordinate based on our roads data. We also have route and milepost. So if you are on a highway and you break down, and let's say you're on I-15 at mile marker 309, this is exactly where you are, so you can tell AAA or somebody to come find you. This is used a lot with public safety and UDOT type things. And just like the addressing, we do a reverse way, so you can put in a coordinate and figure out what route and milepost you're at. And then to access the SGID, we have the searching. And searching allows you to, for instance, find out what counties start with K, for instance. So we have Kane County as the only one that starts with K. And then we kind of have some meta endpoints that let you see the data that we have available if you don't have a database client or something to do that. So in bioscience, we have dominant vegetation, fire perimeters, wildfire perimeters, and then you can take that deeper and view the attributes that you can query on a data set like that. And the last one has never been implemented. So that is the 5-minute, 3-minute intro into the web API. And the web API uses API keys to authenticate your requests. This is mainly for authentication. And to get started, you go to, oh yeah, so I should tell you that this website is api.mapserve.utah.gov. If you click on console, you'll end up at developer.mapserve.utah.gov. Then you can log in. So when you log in, you end up at this screen, and then it's self-service, so you can generate an API key. And these are complimentary to use, and you can make a whole bunch of them so that you can use them in different applications and see what applications are being used. Like, you know, it's kind of like analytics, right? And so on top of the API, since not everybody likes to write code or knows how to write code, you can go to our website, gis.utah.gov. You can go to data and then addressing. And then we have a couple different ways to make interacting with our API easier. So the one I'm going to show next is our desktop API client. It's a downloadable app that you can install on Mac or Windows. And it ends up looking like this when you have it downloaded. And so we tried to really guide you through the process of geocoding with this tool. And so it tells you to go to the developer console, create an application or an account, confirm your email address, create an API key with this pattern. And you can see that would be like right here. So if I did UGRC API dot whatever it told me to do, this right here, I'll just copy it, paste it in here, create. It gives me a key. I can come over here and paste it in, and it checks that that key is valid. I can click next, and then it describes to me how the data is needs to be kind of formatted in your CSV that you're going to geocode. And an address is kind of made up of these 4 parts. So you have a house number, you have a prefix direction, you have a street name, and then you have a street type or a suffix direction. And if I choose a file here, it reads the fields from my CSV, so it kind of expects you to have a header row. And then it makes a best guess at what your street and zone field are. And then it shows you the first row of your data so that you can verify that this is, you know, choosing the right fields. And then if you hit next, we can choose the spatial reference, kind of like Greg showed with the projecting. The Utah spatial reference that has the least amount of distortion and is the state standard is this UTM Zone 12 North, which has a well-known ID of 26912. So if you want to do measurement or area calculations, that would be the spatial reference to use. 4326, which is what he projected to, is lat long and is available to be displayed on OpenStreetMap in dbeaver, for instance, like Greg showed. And another one is WebMercator, and this is the spatial reference that you use for most online mapping tools. So I'm just going to keep it as 26912 for now. There's 33 addresses in my CSV. It might take 11 seconds to run. We hit start. We see, you know, our active match rate, our average score, how many failures, how long it's taking. And when it's done, we get a file to download. And that can be then used to enhance your data. You know, you can apply those locations back into your database or do whatever you want with it there. So moving on, we also make clients to interact with our API for front-end JavaScript developers, mainly React developers. So if you search NPM for our namespace at UGRC, you can see we have a layer selector, which allows you to switch between base maps. We have Dartboard, which is the tool that allows you to geocode and zoom a map to the result. Sherlock is the client over our search API, so it allows you to create type-ahead experiences with any data set in the SGID. And then we have two other ones that aren't really worth discussing now, but we will look at another sample website that we have, just atlas.utah.gov. This is a template that we have just to create a simple map viewer. And this right here, this find address is a dartboard. So if I zoom in, you know, I can find where Zach's been hanging out on Bear Lake playing pickleball. This find point of interest is Sherlock, and this is pointed at a place names data set. So I can type in things like Delicate Arch, and we can go zoom to Delicate Arch from the top. It's not very impressive when you look at it from the bird's eye view. It just looks like a rock. And then, you know, find city is Sherlock pointed at our municipal boundaries data. So you can type in Alta and go to the town of Alta and see how snowy it is up there. A couple more examples of using our data or using our API to enhance like kind of your apps. You can, this is parcels.utah.gov, and you can click on some parcels to see, you know, who owns the land under, you know, a hiking trail that you're on. And, you know, it's this person here, and they're being kind enough to let you walk through their property. Oh, one thing I forgot to show you in Atlas is that if you click on the map, this right here, reverse geocode. This right here, city, like municipal search based on shape. Zip code search based on the you know, the click point. County search, same thing. So, you know, we can do raster queries and get elevation, the land ownership, national grid, and this is the date of when the imagery was flown. So you can really see that there's a lot of opportunity for enhancing the applications that you build. And I'm going a little long on time. PLSS, another example, you click on a point, you can see the county it's in and some other information about its data. Mapping library that we use to build all these tools with the Utah base maps and everything is from ArcGIS. It's from the Esri vendor, ArcGIS Maps SDK for JavaScript. We have an enterprise license for this that all state agencies can take advantage of. So you can use this API or this SDK to build mapping applications into your applications for no cost at all. So you don't have to pay Google or Mapbox or anybody to use and build these kinds of features. And with that, I think I'm going to pass it over to Zach to talk about our awesome base maps.
All right, so I'm going to pick up where Steve left off with Atlas and talk about our base maps. So rather than talk about technical stuff, I'm going to show you pretty pictures. So rather than listen to me drone on about base maps, I'd encourage you to go to atlas.utah.gov and take a look at them yourself while I'm talking, especially. So we started publishing base maps about 15 years or so ago as a way of showing off contents in the SGID as well as showing off some of our partners' data. We figured that if we're going through the trouble of aggregating all this data, why not show it off? So there's two main ways our base maps are being used. One by just general GIS users that need a reference base map to overlay their data on. They can do this without having to reinvent the wheel of adding all these data layers to their map and symbolizing. They can just add a base map, add their data to the base map, and they're off to the races. And equally, or maybe more important, all these base maps are being used in our web applications, as well as other state offices as well. So today we're publishing 3 or 4 different base maps, depending on how you want to look at it. Overlay or hybrid, light, and terrain. And so right now we're looking at the overlay base map overlaying on our raster imagery. So this kind of, we also call this one hybrid. So this base map was intended to be overlaid on imagery. The vector data is there to provide reference, and the imagery is kind of the primary focus. So we kind of kept the symbology to a minimum, no polygon fill layers to obscure the imagery, etc. The next base map I'm going to talk about real quick is light, and you can imagine where this base map got its name from. So the light base map is just basically muted colors or just grayscales to show off the data that's being overlaid on top of it. So the overlay data on top of light is the main attraction, is kind of the what you want to see, and this base map isn't there to take away from the data that you're trying to show. And then finally, our last base map is terrain, and like light, the name is pretty obvious. Terrain is there to show off terrain features, topography, kind of give you a general idea of elevation, land ownership or land covers, kind of generalized vegetation types, etc. So each base map we have, depending on the base map, there's about 30 to 40 unique layers in there, and the base maps are being continually updated. Once one base map finishes caching, another one begins. Depending on the base map, they range from about 25 to 75 gigs in size, and anywhere from 2 to 5 days to cache for overlay and light, up to about 40 days to cache for terrain. So why use our base maps? Well, one of the biggest selling points is they're free. Google and Mapbox, you're going to pay subscription fees to use those, where you could use ours for free. Many other state offices are using them as well. Another reason to use our base map is they're constantly being updated. Once one finishes caching, another one starts caching with updated data. And another reason, since we are data aggregators and curating the data that's in our base map is always current as well. And Greg kind of hit on this a little bit earlier. Since we're keeping our data current, we're also sharing our data with Google to help them keep their base maps current as well. And we're also forwarding our data on to the U.S. Postal Service to help them with their data and keeping their routes up to date as well. So it's kind of, since we're data aggregators, it doesn't make much sense for us to silo our data. And so we're trying to keep all of Utah up to date with Google and the Postal Service. So, and finally, another reason why to use our base maps is if you were to find a problem, it's super easy for us to spot cache an area and update. So say that there is a problem within the Tooele municipal area, it's super easy for us to cache that quickly and update all of our base maps. There are some changes ahead for us. Currently, we are serving raster tile base maps. So when our base maps are being cached, we're generating millions of PNG and JPEG tiles, so that when your client makes a request, we're returning, um, PNG and JPEG images for that extent that your client is requesting. In the future, we do have historical imagery, Eric, that can be found in raster.utah.gov, but we don't have any of the historical imagery in the base maps. So we're going to be moving to vector tiles. It'll be a game changer for us. So where a raster base map may take days for us to cache, or vector tiles, we can recache a base map in a matter of hours. And where these raster base maps are gigs in size, upwards of 75 gigs, we can create vector tiles for the entire state and have them a gig or under. So the vector tiles will be a lot more portable than the raster, and they also render a lot better. So with that, I'll turn things over to Sean.
To start things off, let's first talk about the evolution of GPS. So not all GPS is the same. As you can see, we've got examples of recreational grade, which would be an example of your cell phone. Mapping grade, which cell phones are about 3 to 4 meters in accuracy. Mapping grade is about 1 meter, and survey grade is 1 to 2 centimeters. Survey grade is really becoming the standard, and especially for trying to maintain the data in the SGID, we're trying to improve that data and make it as precise as possible. And because it is possible, it's really becoming expected to have survey grade data. So the big questions that I'm trying to answer is how can we achieve centimeter precision, and why do we need centimeter precision? I'm going to show you some use cases and examples of this. But first, understand our project. We are maintaining a GPS network that we call the Utah Reference Network GPS, Turn GPS. And this is the evolution of that network starting in 2005 with just 5 stations that we demoed. And moving through the years, we've evolved to the point where we've gone through a point where we've covered the entire state of Utah and even expanded beyond the bounds of Utah. This is what it really looks like right now. And I guess you're probably wondering, what is a GPS network? GPS network is a high precision global navigation satellite system providing real-time corrections with centimeter precision within the footprint of the coverage area. So anywhere you are within this footprint, you can achieve centimeter precision if you have all your ducks in a row. And the requirements of that are you need a receiver capable of receiving survey grade real-time corrections. You need a cellular data plan, and you need a subscription from the UGRC. Once you have all those requirements in place, somebody in the field that has that kind of receiver can actually connect to the system, and we will start streaming real-time corrections to you, which will allow you to receive centimeter precision. What do these devices look like? Well, this is an example. I just kind of splattered a bunch on the screen, but they come in all shapes and sizes. And just like with the evolution of the accuracy, everything is evolving with GPS. So we're expanding into many different disciplines. It used to be that everything was surveyors out using this system, and now it's drones. It's all kinds of uses, and I'm going to go through a few of those. This is an example of what the difference is between just a regular GPS unit and a survey grade unit that's connected to our system. In the first number 1 there is showing a car that's connected to our system, and then a GPS receiver that's sitting in the same car that's not connected to our system. We're driving this car in the left lane in example 2. And then in 3, we're seeing that the screens are split. They're connected to each of those receivers. The left lane obviously shows that it is driving in the left lane on the imagery. But on the right lane, you can see the one that's not connected to our system is clear over on the sidewalk. So positioning with our system can actually put you in the correct location. And this is just one example of the use. So scientific monitoring has one use, and I'm going to show you an example. Back in Japan in 2011, there was an earthquake. This is an animation of the earthquake happening. They have a lot of GPS receivers that are collecting data and streaming real time like our network is. And they've taken all of that data and they've put it into an animation to show what happened during this earthquake. You can see before I start, the star area is where the epicenter is. And you can see as it moves from the epicenter across Japan, how much movement you're seeing. The left is showing the movement in horizontal, and the right is showing the movement in vertical. So an example of monitoring. Watch this as it happens. It takes about 1.5 minutes to go through, but this is showing all of the stations, the GPS stations like our network on the left side there in white, not moving. And as soon as the earthquake begins to happen, you can see how much this moves. It's amazing how much movement they got in horizontal displacement. You look at that color scale, and it's showing 400 centimeters. So 4 meters in horizontal is what it's moving. In vertical, you're seeing that it's almost 1 meter. So amazing potential of this technology and what we can do with a GPS network and its data that it collects in real time. You can see that it happened over a pretty short span. I mean, you're talking a 5-minute span, 6 minutes now, but huge amounts of displacement. And because we're short on time, I'm going to skip past this, but this is pretty amazing, an amazing example of what can be done. Another example is, this is a use case the University of Utah is using for cancer treatment at the Cancer Treatment Center, where they're trying to move some time-sensitive medical supplies. People that are needing chemo treatments at one location, but the medical supply is at another location. It'd be nice to just fly those with a drone to that location. The problem is there are restrictions on flights, and you can only fly in certain corridors. And so the GPS network connected to a drone can actually make sure that it flies in a designated flight corridor. This is another monitoring project that we're working on with on the Great Salt Lake. We've installed a GPS station out there where we can monitor the water level as well as the causeway movement. We have this in place and it's going to be online soon. We're also going to start looking at using the data that's coming to that receiver to determine water levels by using multipath or reflected signals from the water surface to the antenna to then calculate how much that water is moving over time. Utilities is another example. Dominion Energy is one of our biggest users, and they use Turn GPS to collect precise locations on utility infrastructure for safety purposes. There have been times when a mudslide has covered up infrastructure like a valve that needs to be turned off. And because they've collected that stuff with our network, they can then go and navigate back to that valve, even if it's covered up, and get to it quickly so it can be turned off. And a lot of our other customers are using this for feature inventory as well. Robotics is another use, using the GPS network with the tiny robot to do paint precision lines for project layout. This is a pretty cool instrument, and there are several users in the valley that are connected to our system, getting precise robotic corrections. Also, drones are being used by the USDA to collect data on potato fungus monitoring. So there are areas where fields have been corrupted, and they do flights and take imagery of areas so they can determine whether or not they need to burn out a portion of the field before it gets into all the other crops. Agriculture, using the GPS network to save on fuel and fertilizer. You can see this tractor is running and connected to our system, and its precision is about 2.5 centimeters. So they stay online for long periods of time, and they're not overlapping or redoing parts that have already been done. Lawnmower, this is an example of a decorative lawnmower line within Daytona Speedway. This was connected to a network out in Daytona so that it could stay on on the lines that it needed to. Precise painting, using GPS network for precise sports field painting. This has become a big use in our valley. We have several customers doing that right now. Autonomous GNSS solutions, you can see in the photos here that all of these vehicles do not have a driver, but they are running. So they're doing yard shifting, agriculture, vehicles, mining, sod cutting, all different kinds of uses, but all connected to a GPS network. We're working with UDOT on this autonomous vehicle project. They have a roadside unit that's located at an intersection. As a car approaches an intersection and it's connected to our network, it's able to see where it is in relation to everything in the intersection, including other vehicles that are connected to the network. It can help provide information about what's coming up. If there are problems or alerts that need to be given, it can come directly to the car and let them know there are problems within the intersection. So to answer the questions, how can we achieve centimeter precision? Really by using Turn GPS. For more information, please go to turngps.utah.gov or contact me or anyone else from the UGRC. Why do we need centimeter precision? Achieving precise location saves time, money, and improves emergency service response times. Really, the sky is the limit. And if you think of another way to use precise location and want it in real time, then contact me and we'll try to do a demo and try to work with you and your agency on using the GPS network. Thanks for your time. Over to you, Greg.
Okay, excellent. All right, thanks, Sean, Zach, Steve, and Jake for those great discussions and chat. I think, if you think about it, you'd be hard pressed to find an agency in the state who does not have geospatial data in-house. So as you go back to your agency, BTS, and whatever your workflows and processes are, think of us, think of this, and see where you might be working with geospatial data and how you can use some of these tools. This was just to kind of whet your palate today and just get you thinking, but you can always reach out to us and for further questions or explore our offerings. But yeah, the other thing, is we strive to have our data as fair, findable, accessible, interoperable, and reusable. I'll take that first F and also say free. That is a huge bonus to folks here in the state, that our data is free and will remain free. So that in and of itself is just enough reason to explore, go out and just explore, see what we have to offer there in a variety of ways.